Okay, today we're going to talk about trapezoids. Trapezoids are a four-sided figure, so a quadrilateral with one pair of opposite sides parallel. So that's our definition. It's just a quadrilateral with one pair of opposite sides parallel. Our bases are those two parallel sides. So in this case, our bases are TR and PA. And because they have a start and an end, they're segments. So we just put that one line on the top. Our base angles are the angles that are created by our parallel line and one of the legs of the quadrilateral. So our base angles are angle P and angle A, and then angle T and angle R. And there are two different types of base angles. T and R are our upper base angles, and P and A are our lower base angles. So basically the pairs, so the upper and lower base angles, are created by one parallel line in either of the legs. So that's how we're talking about angle P, and angle T and R are the other pair of base angles. The legs are just on the side of our figure. So TP and RA, or non-parallel sides, are our legs. In our trapezoid, we have different qualities and characteristics than our parallelogram. So forget about everything that you know about your parallelogram when you're dealing with trapezoids. So really all we know right now is that we have all angles adding to 360 degrees because it's a quadrilateral. In addition to that, we know that consecutive angles between the bases are supplementary. Okay, so more specifically what that means is one upper base angle plus one lower base angle adds to 180 degrees. So if we're finding the measure from B to A to D, right, from B to A to D, this is our lower base angle. Our consecutive, right, upper base angle is 102. 102 plus whatever this angle measure, you can say measure of angle BAD, or you could label it as X, adds to 180 degrees. We subtract 102 on both sides, and we get the measure of BAD is equal to 78. You can also think about these as same side angles, right? They're on the same side, so they're supplementary. That's also a thought. So our isosceles trapezoid is next. So with our isosceles trapezoid, we have all of the characteristics of our regular trapezoid, but additional ones. So it's a quadrilateral with one pair of parallel bases, and also congruent legs. And remember, those legs are just the non-parallel sides. So again, it has all of the properties of our trapezoid. So we have one upper base and one lower base angle congruent. We have two parallel lines, right, or one pair of opposite parallel lines. In addition to this, base angles are going to be congruent. So more specifically, we can say angle P is congruent to angle A, and angle N is congruent to angle S. In addition to that, we can say diagonals are congruent. So this entire diagonal, let me change colors so we can see it. So this entire diagonal from S to A is congruent to this entire diagonal of N to P. Their diagonals are equal. We also know, which I didn't include, but we were given in the definition, that legs have the same measure. So this leg is congruent to that leg. And we still have that quality of a regular trapezoid of one upper base angle and one lower base angle as supplementary. So let's figure out some of the properties or some of these angles given in this example problem. We are given the measure of angle P, or of angle S, sorry. Angle S, right, if we're looking at our properties of the trapezoid, will have the same measure as angle R. Angle P, right, will have the same measure as angle Q. So right away, I'm going to change one of these. Let's say measure of angle R. So I'm changing this to R. Measure of angle R will be 70 degrees. To find the measure of angle P and angle S, right? Angle P is an upper base angle, angle S is a lower base angle. So I'm taking 180 and subtracting 70 from it to get 110. Because this 110, right, upper base angle and the lower base angle must add to 180 degrees. Angle Q has the same measure as angle P, which we get 110. We have one more property of our trapezoid, which is the mid-segment, which is really similar to our property of a mid-segment in a triangle. The mid-segment in a trapezoid is the average of the bases. So if we were to take the measure of PQ and add that to the measure of SR, divide by 2, we'd find the measure of AB. AB is the mid-segment. Okay, PQ is base 1, SR is base 2. It does not necessarily matter the order that you add those bases together. So the formula that I like to use is just mid-segment. The measure of the mid-segment is equal to base 1 plus base 2 divided by 2. So instead of this formula here, I would focus on this because this is going to be the formula that we use for all of these mid-segment problems. So let's give this first example a shot. So we want to find the length of the mid-segment, right? So we want to find the mid-segment. I'm just going to label it as X. If PQ, so P to Q, which is our base 1, is 21. If SR has a measure of 25. So I'm going back to my formula. So mid-segment is X. The first base, base 1, is 21. Base 2 is 25 divided by 2. So in this case, it's a simple, right, we add the top first and then divide by 2. So we'll get X is equal to 46 divided by 2. The mid-segment measure is 23. And we're done. Okay, let's find the measure of each of these angles in our isotrap. Okay, here, because it's an isosceles trapezoid, we know the legs are congruent. Therefore, because in its isotrap, we have upper base angles congruent and lower base angles congruent. So if we know angle S is 50 degrees, right, we also know the measure of angle R, which is 50. Okay, now to find the measure of P and Q, think back to our properties of a trapezoid, right? One upper base and one lower base angle have to add to 180 degrees. So to find the measure of angle P, we're going to take 180 and subtract it from 50 degrees, right? One upper base plus one lower base adds to 180. So measure of angle P is 130. That means, right, if P is 130, then Q has to be 130 as well. Okay, excellent. let's move on to our other trapezoid problems. So example 2, right, we're trying to find the measure of x and y. Now, we have to decide whether this is an isosceles trapezoid or a regular trapezoid. What's given to us is we have one pair of opposite legs parallel, right? That's all. We don't have legs congruent, so we can only say that this is a trapezoid. In our trapezoid, we know that one lower base and one upper base angle, right, are supplementary. So we can add, right, one upper base and one lower base angle to 180 degrees. So 90 plus 3y is equal to 180. So these add to 180 degrees. Yes, our trapezoid is on the side, but that makes no change to those parallel lines, right? Parallel lines are just those bases. These two would add to 180 degrees. Same thing with these two. What I find helpful with these problems is to actually rotate my paper around so I have the base right on the top and then also the bottom rather than from side to side. And you'll see much more clearly which angles have to add to 180 degrees. Just a suggestion. So now let's continue to solve for y. We'll subtract 90 on both sides, divide both sides by 3. We get y is equal to 30. And now to solve for x, right? X and 148, or 146, right, have to add to 180 degrees. Subtract 146 on both sides, and we get 34. Excuse me. So those deal with the measures of the angles in a trapezoid. For the next two problems, 3 and 4, we're dealing with the mid-segment, right? Because this measure is in the middle of the trapezoid. It has nothing to do with angles. So let's think about our formula for the mid-segment. It's on the top part of this page. You know, mid-segment is equal to base 1 plus base 2 divided by 2. So in this case, right, if we rotate that paper around, or remember that those bases, right, are the parallel sides. 13 is base 1, 29 is base 2. X, that's the mid-segment, right? It's in the middle of that track. So I'm labeling X as the mid-segment, base 1, 13, base 2, 29, divide that by 2. We add the top to get 42. Continue to simplify. We find our mid-segment measure is 21. And then number 4 is really similar again to our mid-segment problem. It is a little bit more complicated, so make sure that you're paying attention closely to each of these measures. So we know that these two measures, those are our parallel lines, right? So that's what we're labeling as base 1 and base 2. We are given additional information that's not in this trapezoid. We know that mid-segment measure is 15. Okay, because we're given a mid-segment, I'm going to use the formula. And plug in the given information. Given information is the mid-segment, which is 15. Base 1, which is this entire algebraic expression of 2x minus 2 plus 3x plus 2. Those are all of the 8 bases divided by 2. We want to combine and simplify the numerator. So I'm just going to rewrite that entire problem with the 2x and the 3x added together. Negative 2 plus 2 drops away, and we're given that it's over 2. Now, think about what we can do now. Let's set 15, right, over 1. From here, it's a cross multiplication problem. So 15 times 2 and 1 times 5. X. Divide both sides by 5, and we get x is equal to 6. To find the length of JM, plug it back in.